So solving simultaneous equations is today's aim. So what are simultaneous equations, and solving them either graphically or algebraically. We'll focus on the algebraic technique because we've not got some graph plotting software in front of us, but I'll show how you can use autograph as a piece of graph plotting software to plot the graphs and look for the solution that way. And then we'll discuss the advantages and disadvantages of the two methods. So, for example, here's an equation. (15x minus 3y equals 40). X and y numbers, we don't know what they are though. As it stands, there's no way I can solve that equation because, got more than one unknown. If I wanted to find x, I'd need to know what y was and vice versa. Okay. However, I also know that for the same scenario, this could be some situation where I'm taking some measurements and x and y are resistance values in a circuit. And I put different voltages across, and I notice, for example, that 15 volts across the first one and 3 volts across the other, I get 40 amps current to say. I'm just making something up here. And then I change the situation, same resistor values, but I then have that 20x plus 3y equals 50. Now, I've got two equations. And two unknowns. So what I do is I try and solve them simultaneously, hence simultaneous equations. I don't know what x and y is, but I know that we've got the same scenario for both, or not the same scenario, but the same values. So I know that x and y, whatever they are the same in both equations. That's a given. It must be the case to be able to solve them simultaneously. So 2 equations, 2 unknowns, solvable. 3 equations, 3 unknowns, solvable. For every unknown, I need an equation, a different situation, using those values to be able to solve it. And then, in theory, I can solve it. However, I just made up those 2 equations, and completely off the top of my head. So the first thing I need to do is ask myself the question, is there a solution? Is there a value for x and y that satisfies both of those equations? The easiest way to find that out is to plot the graphs. Because if I plot them, I'll get 2 lines, and if there's a solution, they'll cross, because where they cross is where x and y are the same in both equations. So I get myself some graph plotting software, and I plot them. So this graph plotting software is on lots of the computers around the college, and actually I'm hoping to persuade Berlin, so I'm glad this is going on video, to buy the updated version of this and then put that on all the computers in the college. Okay, it's called Autograph. You can get your own copy of it, student copy. I don't think it's massively expensive, but you do have to pay for it. There are other graph plotting softwares that are free. I think Google does one and others, so you can actually get them. But I like this one in particular. So if I want to enter that first equation, I just hit this button here. The x equals the add an equation button. That's this button up here. If I can't find that, I just go to equation and then come to the drop-down menu, enter equation. So enter the equation, and then we go back to the first one we want to put in, which is 15x minus 3y equals 40. So I just type in 15x minus 3y equals 40. What would I expect to see if I hit OK? Y curved. OK. Any other options? Yeah, that's right. It assigns x values and calculates y. So, and then plots the points and puts the line through them. What do you think the line would look like, though? Yeah, okay. Straight line, James, because x and y are linear. For every value of x, y is just times by some number, add, subtract some number. It's not x squared or any other value. So linear equation, straight line. Once I've got the equation, I can use these buttons. For example, I can use this button to zoom out. So that zooms out on the axis. And if you press in the middle, when you do it, click in the middle, it zooms outwards. I think. Oh, I didn't press that button, right. Zooms out. So allows you to see more of the graph. If I want to zoom in, I hit the zoom in button so I can zoom in and give a closer look. If I'm interested in one particular part of the graph, I can zoom in on a particular part using the zoom in box. So it zooms in on that bit. So at the moment, though, I want to zoom out because I'm going to put another graph on here, another line on here, and I'm looking for where they cross. So now I go for the second equation, 20x plus 3y equals 50, and type that in. So new equation, and I've forgotten it, 20x, what's the other one? Plus 3y equals 50. Hit return, and they cross, okay? It looks as though they cross pretty well on the x-axis, but not exactly, I can see that. So what I need to do now is zoom in on that point. So I know there is a solution, that's the first thing. I know there is a value of x and a value for y that satisfies both of those equations. So if I zoom in on that point, I can find out what they are. So zoom box in, which is this one here. Zoom in on that point. Every time I click it, it zooms in. And I can estimate values for x and y. So looking at this curve, it looks as though x is around about 2.572, something like that, and y is around about negative 0.47, 48, something like that. Okay, so I can zoom in and get the values. X equals 2.572, y equals negative 0.47, and the more I zoom in, the better my value. But it's always an estimate. The graph is, you're zooming in on the graph and getting an estimate for the values. The algebraic solution will give you the exact value. So there are my rough values. I've got y equals negative 0.47, say, and x equals 2.572. Oh, no, what's going on here? 2.572. So let's put this in the note. No, didn't mean to do that. Yep. So you'll see that on the video. Never mind. So let's put that in to the notes. And here they are. Now I want to try and solve these things algebraically. So let's go back to the equations. I know I've got solutions now. So a quick test with autograph would tell me that there is a solution. What we want to do now is solve them. Let's look at solving them algebraically. So I want to solve these now algebraically, and there's two methods I want to look at. One is by elimination and one is by substitution. The elimination method is probably the more straightforward one and tends to work only with fairly straightforward simultaneous equations, i.e. linear like this. If the equations get a bit more complex, then we tend to fall back on the substitution method. So that's the more powerful, the more general method. So if you're going to learn just one, learn the substitution method. But let's look at them both. The elimination method involves getting either the x's or the y's the same in both equations, and then eliminating by adding or subtracting. So in this particular case, Warren, because the y's are already the same, we don't need to do anything to the equations to make them, sorry, Russell, to make them the same. So therefore, I just add them together. 3y plus minus 3y, gone. Okay? If they weren't the same values, I'd have to make them the same. So for example, if I want to make the x's the same, I'd think of a number that 15 and 20 both go into, which would be, well, 15 times 20 would work, but there's probably a smaller one. No, probably not, actually. Oh yeah, 60, they both go into 60. So I'd multiply 15x by 4 to get 60x, and I'd multiply 20x by 3 to get 60x. If I multiply 15x by 4 to get 60x, what must I also do? Yeah, times that by 4 and that by 4. Okay, so that's the idea of this elimination method. But in this particular example, I don't need to do that because the y's are already the same. So all I do is add 1 and 2, or in fact I'll probably just write down equation 1 plus equation 2, which will give me 20 plus 15 is 35x equals 50 plus 40 is 90. So therefore x equals 90 divided by 35, which is 2 point something. Sorry? Exactly? Right. So in other words, to three significant figures, yeah. Which agrees, I think, with the graphical method that we looked at. We had 2.572. So, okay. Now we've got the value for x. What do we do to get y? Correct. We substitute into one of the equations. So I substitute x back into, say, equation 1. So substitute into 1. So what is equation 1? 15x minus 3y equals 40. So it's 15 times x, which we know now is 90 over 35, minus 3y equals 40. Actually, 5 goes into both of those, so that's actually the same as 15 times 5 into 90 goes 18, isn't it? Over 7 minus 3y equals 40. I still know why, but I try and stick with fractions so I get an exact answer. But I'm sure you could use a calculator and do it. So what's 15 times 18? That's 180 plus 90. It's 270 over 7 minus 3y equals 40. And then I might be tempted to reach for a calculator. Okay? To finish off that, find out what y is for me, please, by solving that equation from there. Looking at the graph, the cross looks like x equals 3.5 and y equals 2.2, roughly. But let's try and solve this algebraically. Luckily, for you, y's are nice whole numbers, so I'd go for y if I were you. What can we do to make y's the same? No, 4 doesn't go into 14, does it? Yeah, it's 28, isn't it? So they both go into 28. So I'm going to multiply equation 1 by what? I want to make 28y. So what have I got to multiply that by to make 28? Right, so I'm going to multiply equation 1 by 7 and equation 2 by 4. Oops. Times 4. So then I'm going to get 2 new equations, which I'm going to enable 3. I don't know why it's doing it. I have to recalibrate it while you're doing this. And 4. So work out what the 2 new equations are, label them 3 and 4, and then decide how to eliminate y, and then find x, and then once you've got x, find y.